Welcome to Spelling Bee Ninja, the podcast dedicated to fostering curiosity and knowledge in science. Each episode delves into fascinating topics to inspire your learning journey. We invite you to subscribe and join our community where education is a priority, and together, we explore the marvels of the world around us. Today, we will uncover the groundbreaking ideas of Nicholas Copernicus, the brilliant mind who suggested that our planet Earth orbits the Sun, appending centuries of established beliefs. Let's dive in. Nicholas Copernicus, who lived from 1473 to 1543, was a Renaissance mathematician and astronomer. He is best known for proposing the heliocentric model of the universe, which claims that the Sun, rather than the Earth, is at its center. This idea was revolutionary. For over 1400 years, the prevailing belief had been that the Earth held a special, central position in the cosmos due to the teachings of the ancient astronomer Ptolemy. Ptolemy's geocentric model claimed that everything in the universe revolved around the Earth, including the Sun, Moon, planets, and stars, all neatly looping in perfect circles. However, this intricate system developed major flaws, particularly the puzzling phenomenon of retrograde motion, where planets appeared to move backward in the night sky. To address this, Ptolemy introduced the concept of epicycles, tiny circles within larger circles to account for the observed planetary paths. By the time Copernicus entered the discourse, the complexity of Ptolemaic astronomy had ballooned, with countless epicycles juggled to make the model work. Copernicus recognized that a simpler solution was necessary. He took over 30 years to meticulously develop his heliocentric theory, inspired by ancient Greek philosophers such as Aristarchus, who had put forth a sun-centered universe centuries before. Unlike Aristarchus, however, Copernicus went beyond suggestion. He sought a structured, more elegant explanation of celestial movements. In his model, the Sun occupies the center, with planets, including our Earth, orbiting it in circular paths. Not only did this elegantly explain retrograde motion as simply Earth overtaking another planet in its orbit, like passing a slower vehicle on the highway, but it also fundamentally shifted humanity's understanding of our place in the universe, an unsettling revelation for many devout 16th-century individuals. Interestingly, Copernicus did not witness the full impact of his work. He published his seminal writing, On the Revolutions of the Heavenly Spheres, in the year of his death, 1543. The book presented a thorough outline of his mathematical and astronomical theories, but Copernicus understood the potential backlash from religious authorities. To shield himself, he deduced that the best way to present his ideas was as a mathematical hypothesis instead of a definitive assertion about reality. This strategy was evident in how he dedicated his book to Pope Paul III and included a preface by Lutheran theologian Andreas Oegender, who framed the heliocentric model within a mathematical context. Copernicus's concerns were well-founded. In 1616, the Catholic Church banned his book, which stayed on the index of prohibited books until 1835. The implications of Copernicus's heliocentric model reached far and wide. By relocating the Earth from its privileged perch in the cosmos, he effectively challenged the belief that humans were the focal point of divine creation. The idea that our planet was just one of many revolving around the Sun was disconcerting for many. Yet, the brilliance of the Copernican model lies in its accurate depiction of the order of the planets in relation to the Sun, which remains accepted today: Mercury, Venus, Earth, Mars, Jupiter, and Saturn. Copernicus's contributions paved the way for what became known as the Copernican Revolution, fundamentally changing the landscape of astronomy, physics, and philosophy. Despite the clarity of his arguments, Copernicus faced significant resistance. Among the critiques was the absence of observable evidence for a moving Earth. Skeptics wondered, if our planet was traveling around the Sun, why didn't we feel that motion? Why wasn't debris flung off its surface? And why were we unable to observe stellar parallax, the subtle shift in stars' positions as Earth courses through its orbit? Copernicus astutely reasoned that stars were immensely distant, making parallax undetectable to the naked eye, a conclusion difficult for many to grasp at the time. It wouldn't be until nearly 300 years later that technological advancements, specifically the invention of powerful telescopes, would validate Copernicus's predictions. In 1838, astronomer Friedrich Bessel made the first successful measurement of stellar parallax, confirming Copernicus's intuition. Although his ideas were radical, a handful of scholars could see the merits of Copernicus's heliocentric theory, even if the majority dismissed it, as it conflicted with the teachings of Aristotle and certain biblical interpretations. Advocates like Johannes Kepler would later build on Copernicus's foundation, developing the laws of planetary motion that replaced perfect circular orbits with ellipses. Consider Galileo Galilei, who leveraged the telescope not just to explore the cosmos, but also to uncover evidence supporting the heliocentric model, like the moons of Jupiter and the phases of Venus. Galileo's findings regarding Venus were particularly compelling. They demonstrated that Venus underwent phases similar to the Moon, which could only be logical within a heliocentric model where Venus orbited the Sun, not the Earth. Interestingly, Copernicus didn't originate the heliocentric concept. Aristarchus had suggested a sun-centered universe centuries earlier, but those ideas had failed to gain traction, primarily due to the strong preference for the geocentric perspective upheld by Aristotle and others at the time. Acknowledging his predecessors, Copernicus cited Aristarchus as a pivotal source of inspiration. Additionally, he referenced another ancient thinker, Philolaus, who posited that Earth moved around a central fire, a daring allegory that shook the status quo, revealing that the notion of a moving Earth had been debated long before his time. Beyond astronomy, Copernicus left an indelible mark in various fields. An economist, he formulated the quantity theory of money, suggesting that as the money supply rises, so do the prices of goods, a foundational theory in modern economics. He also dedicated part of his life to medicine, treating impoverished individuals at no cost, and spent years as an active canon in the Catholic Church, engaging in various political and diplomatic affairs. Truly, he was a Renaissance man, much like Leonardo da Vinci, but on a different spectrum of inquiry, his brilliance illuminating the pathway of scientific exploration. Copernicus's legacy is one of intellectual bravery and meticulous observation. He dared to challenge a widely held belief system that had persisted for over a millennium. By taking bold risks, he planted the seeds of the scientific revolution, inspiring future generations to question dogma and strive for evidence-based answers. His work instilled the profound understanding that in science, simplicity often prevails, the principle now known as Occam's razor. As we've navigated the contrasting realms of geocentric and heliocentric models, we uncovered the significant obstacles Copernicus faced and how his revolutionary ideas eventually reshaped our understanding of the universe. Through him, we learned that the cosmos is dynamic and ever-evolving, echoing the timeless quest for knowledge. In summary, the journey of Nicholas Copernicus is a powerful reminder of how questioning established norms can lead to monumental shifts in understanding. From his groundbreaking heliocentric theory to the challenges he faced, Copernicus exemplified courage in the pursuit of truth. His work not only changed the course of astronomy but also our very perception of humanity's place in the universe. Ultimately, he showed us the importance of seeking knowledge and embracing curiosity in the quest for understanding the world around us. Thank you for joining us in this educational exploration of Nicholas Copernicus and his revolutionary contributions to science. We hope you enjoyed this episode and learned something new. Don't forget to subscribe for more insightful discussions and fascinating topics. Until next time, keep questioning, keep exploring, and keep learning.